So next speaker of the session is going to be Fred Frey and Jonathan Mulholland from Snap Attack. The Atomic Red Team open source project has a long history on the ATT&CKcon stage with a presentation at the first one back in 2018. Sigma is another project that has had a lot of mentions here. And so the next talk is going to take a look at smashing, their term, these tools together to take a look at the best analytics to apply. So please welcome to the stage Fred and Jonathan.
Okay. All right. Welcome, everybody. How's everybody doing? Everybody having a good time so far? All right. Awesome. All right. Very good. So, yeah, we're a new company. We're about 4 to 5 months old. And we have a community release that we're going to be doing today. So we're really excited to share some of our data science research. We're going to be releasing a lot of data sets to hopefully drive forward the detection community and red teams and blue teams working together. Okay. So for introductions, my name is Fred Frey. I've been around InfoSec for probably over 20 years, first 16 of which I've done a lot of offensive CNO operations for military DoD, as well as commercial red team pen tests. Last 6 years has been switched over to the blue side. I never thought that I would trade in my red card badge for a blue one, but it happened. And threat hunting is so much fun. So if any red teamers want to switch to the blue side, we have cookies too. But blue team is a lot of fun. Threat hunting is a lot of fun. It's a lot about investigation. And what I found is in teaching blue teamers or red teamers how to do the blue team side, we've learned a lot of things. So love to talk to you guys more about that. And with that, turn it over to Jonathan.
Hi, everybody. I'm Jonathan Mulholland. I started my life as a physicist. I got my PhD at Jefferson Lab down in Newport News. I worked for a bit at NIST doing neutron physics. And I bailed on all that because the job prospects were pretty grim, and started following my other passion, which is ML and AI. And since then, I've been working in image processing, document classification, document exploitation, and my perpetual fascination, which is trying to apply ML and AI to cyber, which is an extremely challenging problem. So I was super happy when Fred asked me to join the team, and I got a chance to really dig into that problem.
All right, so some of the talk topics today. So we're going to talk about this red and blue smashing together concept. We are going to talk about what we can measure when we do these kinds of things. We're going to talk about a community release at the end, and we're releasing all of our research at the end. And really, I want to talk about like some of our goals and our motivations, right? So, by combining the red teams and blue teams together, really we can measure and identify gaps, right? There's been a lot of good effort, but labeling them with MITRE ATT&CK. So we can actually use MITRE ATT&CK as a backdrop for this whole talk to talk about measuring and effectiveness and validation of analytics. The other thing is there's a lot of great effort from the communities out there already, but a lot of them exist in repos, right? Like GitHub repos and things like that. And while they're really open and very collaborative and very sharing, sometimes the barrier to entry for these is a little too high for some people. So we have some concepts that we think that we can help the community with by bringing these open source communities up into a nice searchable user interface, filterable, and things like that. I actually love the talk yesterday. If you haven't checked it out, Compass. There's a talk yesterday on Compass where they actually did the mapping, and it's up on GitHub. And there's a search page where you can search by MITRE ATT&CK and pull up all of the red team communities and all of the blue team communities all in one place. Those kinds of efforts bring these communities together and strengthen them. Snap Attack, we're trying to even go further. We have probably 80% of all of the analytics that are in and attack sessions that are in Compass, but in a sandboxed environment. So we'll talk about that. But anyway, I really wanted to highlight the awesome work that red team communities, blue team communities, repositories out there are doing. We're a huge fan. We contribute. In fact, I gave a PR this morning. But really good stuff. But wouldn't it be really cool if we could smash these things together? So pause on that. We mentioned that Jonathan is a scientist. He worked actually at a particle collision lab. So one time we were having lunch. I think there might have been beer involved. We were philosophizing on InfoSec, and he was talking about particle collisions, and it really kind of dawned on us. It was like, hey, that's kind of what we're doing in our platform, right? Scientists, they are trying to study the subatomic elements of an atom, And in doing so, it's very hard to measure directly. So what they do is they collide them. And then this backscatter due to the collision is what they actually measure their research off of. So very similarly, we are taking data sets from the red and the blue community and smashing them together in our platform along the labeled lines of MITRE ATT&CK. So here for today's talk, we're actually going to focus on atomic red and sigma. They're two of the most widely supported and popular communities. Thank you, guys. And our goals are to measure hacker behavior by colliding these. So what are some of the types of things that we can measure? So there's a lot of things, but I'll narrow it down to this, and we'll go fast because we're going to jump into each one of these as a research topic. False positives, right? If you study analytic in a GitHub repo in unison, like by itself, that doesn't tell you anything about its true positive or false positive nature, right? Only when you put these analytics into action can you really see how they work. MITRE ATT&CK coverage, same thing. We can actually collide we have the unique opportunity to have a red team researcher apply a MITRE ATT&CK tag to what he thinks the attack is, and then the analytics, the detection engineer applies a tag to what they think it is. But there's some really interesting stuff when you start colliding these together. You can validate MITRE ATT&CK tagging, but you can also find discrepancies and interesting similarities, which Jonathan will go into a little later. And then lastly, analytic similarities. Whenever you have a community, the Sigma community alone has over 1,800 analytics. They're freely downloadable and usable. The quality varies widely, right? So measuring these things is important. But analytic similarities are bound to happen, and we're going to talk about that, around how when you have 1,800 analytics and you bash it up against an atomic and you get these 4 that always hit on the same attacks, maybe they're duplicates, maybe they're similarities. So we're going to talk about that. So before we jump into the data and the research, really briefly talking about the library. So we'll come back to this, but this is what we're I wouldn't say open sourcing, but open free community platform where we're putting all of the data in there. We've ran all of the atomics, all of the sigmas up against each other. It's part sandbox, part detection engineering platform, but it's really it's supposed to be a research platform to uplift our whole community. Our whole goal is to really take blue and red and mash them together. So if you look, actually, I don't think anybody used the laser pointer, so I'm super excited to. Yeah, I'll keep my fire downrange. But if you look at it, the red team, right? So the red team, there's this circle of red team attack sessions, right? Whether that's Metasploit, Caldera, Atomic Red, etc. And then there is, sorry, Jonathan, you're close to downrange. I'll try and not get you. We do have the analytics, right? And those are those repos. And so what we really want to do is measure the validation of these, right? So you have all of these attacks out there, all of these analytics. When you smash them together, anything that matches from a validation standpoint is something that we can confidently deploy. We are confident that that analytic will match that attack detection, right? So that's what we're going to talk about. These represent attacks from a standpoint that we cannot yet detect. And over here are analytics that exist in a repo that are probably valid, but a red teamer hasn't exercised those in a real way and validated them. So our goal is to smash these together more and more. Okay, so I'm going to turn it over to Jonathan.
Okay, great. Okay, let's do a particle physics experiment. So here's all our particles up there. We've got red ones and blue ones. The blue ones are all drawn from the Sigma Community Analytics repo. So every one of those blue dots represents a query from that repository. So there's 1,840 of them. The red dots, so these are our attack sessions. So there's 847 atomic red scripts. We emulated as many of them as we could. We logged it, and then we applied a marker to those logs to show where in that session did the exploit that we're interested in happen. So we've got a timestamp on there, and we've got a process. We've got the process marked. And possibly most importantly is that we have the attack techniques labeled in all of this from the community, which allows us to bridge the gap here. And I'll show you how that works later. 379 of them we were able to emulate successfully, and so that's what's in our pile of particles there. So let's smash them together. Okay, here's the particle collider, the inside of the particle collider from Snap Attack. It looks like a mess, and it's kind of like in nuclear physics. when you've got a mess inside of a detector, you have to hack away at it piece by piece. And you would start by filtering out the noise first. You can see there's lots of noise up there, and then start to dig into what's left over to find patterns and find out what's significant here. So the end goal here is after we dig away the noise, we match the patterns, we try and discover what's in here, is we're hoping to find a set of analytics that are valid, that we can rely on, that don't have huge false positive rates. So another point of this before I continue is this experiment we ran, this is environment sensitive, right? So if we run this in a different environment, we might get a slightly different answer. Okay, so let's clear away some of this. Okay, so this is after we've removed the analytics that are too hot and too cold, right? We saw that some of those hit on everything and some hit on nothing. So we obviously don't want those. And we removed everything that had a connection between the analytics and the sessions that was, they had fewer than, everything up there has between 1 and 20 connections. What is a connection? What is one of those particle traces? We draw one whenever an analytic query hits on a log from one of those sessions. So a line means there was at least one hit on that session up there. Okay, so this is all the connectivity that we're going to dig into and try and find like some sort of pattern. The analytics that we threw away, as Fred mentioned, right, they just didn't validate on anything. They didn't hit anything. That doesn't mean they're bad. So we're going to put those in a backlog and deal with them later. This is fodder for the red team community, right? Like, can you make attack sessions that represent behaviors that those might be able to detect so we can say something about them? For the ones that hit too many of the sessions, if they hit more than 20 sessions, they're probably useless. They're going to hit on lots and lots and lots of events. They're supposed to hit on a particular type of behavior. And if you're hitting on all of our sessions, it's probably not a focused analytic. So we get rid of them. So we're doing this within just open source data. If you've got access to real data, there's a better way to estimate false positives for analytics. Just run it on real data and keep track of what happens over time. How many hits are those analytics getting? So we're actually doing this with some client data. We've got a client that's 50,000 hosts that's let us run our analytics on there so we can get real measurements. We really wanted to share it with you, but that lawyers said that wouldn't be a good idea. So we're keeping this open source, and this is still a pretty good estimate of false positives. So we've cleared those out, right? And like, we're doing this like mechanically, right? This is an empirical measurement. Why is that so important? You can't stare at analytics and figure out what they're going to do. And so we have an example of that here. So this is an analytic that's set to detect PowerShell runs that have an unsafe execution policy. And if you look at what the author thinks, they think that this is going to have some false positives associated with administrator scripts, and the criticality level of it is high. So in the Sigma specs, a high criticality level means that you should forward this to an analyst when it hits, right? So just looking at this, we might suspect, okay, there's going to be false positives, right? Like this happens in the background sometimes. Well, it turns out it hit on every single one of our sessions. So this is an example of one of those analytics that a smear of white lines across it, it hit everything. We probably would have guessed it would have a high positive, false positive rate, but not that it hit on everything. There's going to be lots of analytics like this. The only way to figure out how they're going to behave is to test them and validate them. Right, it's even worse than that. So what if you took the Sigma analytic repository and just wanted to filter on the criticality level? We're going to take all of the critical labels. Is that a reliable way to pull analytics? The answer is no. So we did this measurement here, this x-axis here. I'm going to use, yeah, 2 people using a laser pointer. Look at that. Right, so that x-axis, the quality score. So that is the fraction of attack sessions that an analytic hit that got validated. So if it's 1, it validated. Whoops, sorry. That's why they didn't use the laser. It validated on 100% of the sessions it hit. This is 0. So it's on the left, it's garbage. On the right, it's gold. And it's separated by the criticality level here, right? And you'll notice that the analytics are clustered into 2 piles on either side, which means that it's a coin flip. If you pick a critical Sigma analytic, it's 50-50 whether it's garbage or not. So these authors, while they might be trying to represent the severity of an event, with this criticality measure. They have no way of estimating the probability of occurrence in your system. And so it's up to you to figure that out. You can't rely on them to do this. So you have to do measurements. Okay, so what's the final answer? This is kind of the final answer. So we've taken our graph and we've eliminated all of the noise, we've eliminated all the cold analytics, and now this is every line here involves a validated hit. So that means that the analytic hit on a log that's either the process that was indicated in the session as the malicious activity, or it hit in a time window, and the analytic and the session share a MITRE ATT&CK technique. This technique is what allows us to communicate between the two worlds, and it indicates that there's a shared intent between both the analytic and the session. So this is really key to communicating and bridging this gap. So this common language bridges the red-blue divide. What else can you do with this, right? This is sort of the core set of data. This is actually, I'm not showing this just because I'm nostalgic about physics and it kind of looks like particles. This is a graph data structure. All the data from our system is actually stored in this structure, and those relationships are related. So you can actually do a couple other cool things with it. One is you can just filter by the attack technique. So this is all those points with just the, this is just events having to do with credential dumping with LSAS. So those 5 red dots at the top it's very messy if you put the labels on the graph, so they're like off to the side, and these are the names of the analytics down here. So this is a decision-making tool. So right, if you wanted to figure out what you want to deploy, you might say like, okay, well this analytic here connects to all these different types of behavior that are all LSAS memory dumping or credential dumping. So maybe we want to just take that one and we're covered. Or if you notice there's a few that connect to only one, right? So maybe we want a few analytics that all are tuned to specific types of approaches to this one sub-technique. Or all the data's in here. You could look at log sources, right? So like pick a few analytics from each log source, and then you have like a detection in-depth approach. You're covering your bases.
Yeah, and I think the one thing that's important to know about this is also true sandbox detonation and true analytic hitting in a sim. So this isn't just taking a look at the the label of each and merging them together. This is real world, real life. So I think that's important. And then the other thing is this is all easily searchable, like in the platform that we're releasing today. So you can just go in there with one query, say, hey, show me all the Sigma analytics for T100.3.001, and it'll pop up all of the sandbox detonations from Metasploit, from Atomic Red, from a wide variety of attack sources, as well as all of the sigmas that are actually detecting. And the cool thing is, as a new LSAS gets uploaded to the platform, all of the analytics are run against it in real time, and 15 seconds later, you get the answer. So if you're not sure if a piece of malware will be caught by any community public analytic, you can actually upload it to the platform. I would say that's actually the beta release that's private right now, but we're opening that up in about 4 months once it's really on us for the coding project. But we'll talk about that at the end.
Yeah. I mean, to the point, right? I told you these were the answers. We're giving these away. We're not keeping these to ourselves. So this will be in the community edition. Okay, so a few other things you can do with this, then I'm going to hand it back to Fred. One is once you have these validations analyzed, you can give a much more realistic estimate of what your attack coverage is. If you had just taken the Sigma repository and said, what techniques does it cover? All of those analytics together cover 322 distinct techniques and sub-techniques. If you follow our methodology and filter it down to the good stuff, you're only covering 115 techniques and sub-techniques, which is less sexy, but it's real, right? Like if you colored in your attack matrix with those 322, you're going to have gaps. You're going to have analytics that hit too often to be usable. You're going to have ones that aren't reliable or that haven't been tested. So this 115 number is the real answer that you want to use in your attack navigator illustrations here. Okay, one cool graph analysis technique is you can do a project. So this is all graph data, like I said, right? So you can project this. You can do what's mathematically is called projection onto one side of this chart. So that's a projection of a bipartite network. When you do that, in regular terms, you get similar analytics. So this little petri dish over here is the analytics that are similar. So this is one cluster of similar analytics, and you can turn the math knob up and down on here. So if you want a lot of analytic similarities that are like maybe not so similar, you can turn the knob one way. If you want just very focused, every single pair here is very, very similar, but you'll get fewer of them. So this is an adjustable parameter. But once you do that, you can start doing cool things like deduplication. You can auto label. You can move labels from one to the other, and you can look at the depth of your defense systems you've got. So.
Yeah, so let's take a look at one of these analytic similarities. So first step is an example of MAV inject. And actually, it's funny. This morning, I was actually doing some research on MAV inject, and I was like, okay, is this the right MITRE ATT&CK tag and label? Because you can see that they differ here. So one person has, they both agree on 1055, but there's this 1056 that's different. So, but they're both hitting on the same logs multiple times. So they're very close. And if you look at the code, they're actually very, very close. And it turns out Matt Graber here in the audience actually wrote a blog post on this in 2018. So thank you, Matt, for that. And yeah, so MITRE ATT&CK now has an updated label. I think it's T128. Yeah, it's T128, I think 0.013. So actually, I started typing in a mental note to do the PR request, and then I just put in the PR request right away. But these are the things that we can uncover and clean up the community as things happen. So there's a PR request to change this. But what I would do with these, they're too similar. We need to merge these analytics. The next example has the exact same graph behavior. They're both hitting on a lot of the same attacks, but you can kind of notice that one is actually looking at log source process creation, and the other one is network connections. So some clients might have network connections and not process creation, or remote workers might have process creation and not network connections. So what I would recommend is we keep both of these for defense in depth purposes, right? But we can detect the same behaviors two different ways through two different log sources. Okay, so I'm actually gonna jump to here and then jump back. So we've talked a little bit about this community platform. It's gonna be free forever for the community. Our goal is to lower the barrier of entry for detection engineering. As you saw, I think Johnny and Olaf's talk yesterday, those are the very advanced techniques that we need to mature our community to be able to detect. So if you haven't seen their talk, definitely check their talk out. Process creation is the most prevalent thing that people are developing today. The sad truth is that it's also the easiest for hackers to evade. So by having tools, we're hoping to uncover other data sources that could be valuable for detection that are very, very hard for humans to detect, right? So that's maybe a future reaching goal. But first and foremost, we have to have the data. So through this particle collision kind of platform, we have the data to start that research, we hope. Yep, so today, actually, it should be live right now. If you go to snapattack.com community, we're opening up for read access. We don't have all the code polished for contributing, and we don't have our moderation status up and things like that. But we have probably an open spot for maybe 20 contributors. So if you're interested in being a contributor, please post on that website or on that link. There's a little form. Other community contributions that you've made. We're looking for developers of threat detections that are people that are blogging and putting back to the community. So those will be the first people that we accept into our developer program, which we can accept 20 today. So that's important. All of the analytics and things like that from right now we've seeded Atomic Red and Sigma. So those data sets. We also do have a little bit. I think there's two sessions for Cloud and CloudTrail. A bunch of sessions for Kali Linux and Praetorian. So it's not just Windows. We do have Linux, Windows, cloud, and networking type events that our sandbox can capture. So there's a little bit of that out there. So if I take that and I jump back button works. So research wrap up. We actually started off this talk thinking that we were going to dump a whole bunch of spreadsheets in GitHub and share this out like that way. Our developers were really motivated not to do yet another spreadsheet. And they're like, how much time do we have? And I was like, oh, you probably have a month and a half. They're like, we're going to get a community platform released like today. So it actually wasn't in our original talk. We had to alter the talk. Thank you to the MITRE team for letting us change course just slightly. But now all of these results, everything except the analytic similarity, is like 3 button clicks in the platform. So I'm going to put out a YouTube video showing kind of how you can get all of these answers in the platform. But yeah, so curated set of validated analytics is like filter by validation status, right? Filter by
And
validation
rank.
status.
And rank.
And then rank,
Yeah.
yeah, exactly. False positives, you can filter by rank in there. Backlog of all of the attacks that we have that we can't yet detect. That's a button click away saying unvalidated or like undetected attack sessions. So those are the blue teamers. We're hoping blue teamers swarm on those and say, great, there's all these atomics that don't have a detection. Let's swarm on those. On the other side of things, we have untested signatures. There's a ton of untested signatures that we're hoping the red team can produce either automated breach attack simulation attacks that validate them, or a one-time sandbox capture of that attack. Some things require a lot of infrastructure to set up. Our sandbox, you can do it one time, capture it, memorialize it forever. But that way we can actually validate that these analytics are working. Our goal is that true positive center, right? That purple team. And with that, I think we'll go for questions.
Another great presentation, and another tool drop. So awesome. I actually think I was kind of brainstorming on the side there. It seemed like there might be an opportunity of combining your work and what Lindsay and Scott shared earlier with the control compass. There might be a little bit of play there. Yeah, it's really awesome. And I also appreciate your trigger discipline. I know brave move losing the laser, but it worked out really well. So much appreciated. With that, we have a couple minutes, so I wanted to open it up to the audience. See some hands going. We'll start in the front.
Would be interesting to see or to hear from you guys if you also hit which just is against like a live environment, all kinds of possibilities. So how do those results relate to what you showed in the lab environment?
So just repeating for the audience, how do you kind of coalesce what you're finding in terms of experimentation in labs and applying that to real world? Do typically the outputs and kind of lessons learned translate directly, or is it a little bit more massaging to kind of embed that into real world?
Yeah, so the community edition, we have to have open source community data in that, but that's actually how we make money, right? So we customize these for clients, and so when we enter into a client, we actually run these against and we actually rank them with their data set. That's like one of the first things we do on the onboarding week. But you're right. But for this community is, if anybody has any ideas or of data sets that we can run it against, we would love to work with you guys to get better data. But for the open source community, that's what we can do today.
Another question?
Thank you for this. This is awesome. So one thing that I found a lot of is like those on the red side are really good with building out the attack scenarios, and then being the subject matter experts on that respective technique, they're generally going to be pretty good at separating the chat from like OS artifacts, test runner artifacts, and like be really good at pinpointing the specific artifacts, but they may not necessarily be like really good detection engineers, right? Because they don't have like an operational like corpus of production data to like run their theories against. So like, how do you think through like how your platform kind of like serves that niche of like, I'm a red teamer and I'm a subject matter expert in this technique, but I may not necessarily be good at developing the analytics, but I can point out like clearly what the artifacts are. Like, how do you think through like bridging that divide?
So in short, really nuanced and really great question. But in summary, it was, basically, how does this platform really connect the dots and the knowledge, from a blue, detection engineering, back over to the adversary perspective, but also a red teamer who really knows their trade craft, but might not necessarily know how to write an analytic or understand false positives or validation. What potential do you really see in the platform in this process to kind of connecting those dots?
Yeah, I promise I didn't softball pitch that. That was a great question. A couple of quick answers. One is InfoSec is a team sport, so you don't have to play all roles. Red teamers honestly don't know about logs or detections and things like that. When we talk about, so a red teamer can do their sandbox, throw it up there, add a label saying you should have detected me here, put the MITRE ATT&CK tag on that label, and then walk away. And then a blue teamer pops into their inbox. Second thing is purple team. Purple teaming is so critical, but typically in organizations, it's always once a quarter kind of awesome play date where the red teams and the blue teams get to play together, and that's a paradigm that I feel strongly we need to break down. We have a saying, we want continuous and asynchronous purple teaming, and this platform allows that asynchronous purple teaming. The red teamer can put it up. Blue teamer can prioritize which things they think that they need to detect, pull that off the shelf, rate the detections, test the detections, validate it, and then Kanban style, like work through that work log. But it has to be asynchronous. The chance that a red team and blue team get together in cyberspace is kind of fair. But yeah, team sport.
Thank you for pushing us in the right direction.
Thank you.
Yeah, thanks.
All right, thanks everybody.